So yesterday we talked about scalar versus vector quantities, okay? And we talked about how they can look at the same trip from different points of view. Okay? And we talked about the trip to Home Depot yesterday, where if I go to Home Depot, okay, I travel a distance of like 4 kilometers, but I only actually end up 2.8 kilometers, 38 degrees south and west from my house in a straight line. Okay, they're still talking about the same trip. Both of those trips take the same amount of time, half an hour, okay, but they look different. Okay, one is just talking about what you've done overall, and the other one is talking about what you had to do in order to accomplish that. So the scalar one, it talks about, yeah, I had to follow this road and make these turns and do all this stuff, and I ended up going 4 kilometers. But the vector version of that is just looking at what was your change in position. You started here, you ended here. That's all we care about. Okay? So what we're going to look at now, since yesterday we only did v equals d over d problems with scalar quantities, so distance, speed, and time, okay, today we're going to look at what does this look like if we're dealing now with vector quantities. Now, in Science 10, we're not going to be as complex as 38 degrees south of west, okay, because that brings in trigonometry and all of that kind of stuff. We save that for Physics 20. Okay? Your vectors are going to be very simple, one-dimensional, forward and backward, right and left. Okay, up and down, simple things, okay, where you're either going to have a positive value and a negative value, and that's it. Okay, so for this question here, we have a trip that consists of 2 parts. Okay, anytime we have a trip that consists of 2 parts, we need to remember that average velocity is total displacement divided by total time. Okay? So what that means is I have to look at the 2 parts, figure out how far it went in the first part and the second part, and add that together. And then divide that by the total time. So the time for the first part plus the time for the second part. Right? Rather than finding the individual velocities for each part and then just adding them together and dividing by 2. And we talked about that a little bit at the end of class yesterday. That's not the same thing. Okay? Just adding the velocities together and dividing by 2 doesn't give me the average velocity over the whole trip, because that assumes that they both represent equal parts of the trip. Okay? And they very rarely do. Right? It would be like saying, I think I used this example yesterday, I drive to Edmonton and I drive like all the way till I'm just 5 kilometers from the south end of Edmonton, and that whole time I go 110. And then for the last 5 kilometers I have to go 50 kilometers an hour. My average velocity is not 110 plus 50 over 2. Okay? I went 110 most of the way, and so that part needs to count for my average a lot more than the short little stint I had to go slower for. Does everyone kind of follow me? We have to weight the average in favor of what part of the trip represents more of the trip. Okay? Everybody all right with that? So here's what we want to do with a question like this. You want to just kind of follow along with me and just solve this as I go so you have an example. Okay? The first thing I want to do is the same first thing I always do, which is write down my givens. Except this time, I have to divide them up into 2 parts. Okay, so in part 1, it tells me that the bus travels 100 kilometers north. So what did they just tell me? Distance or displacement? It's a displacement because it has a direction on it. Okay, so I've been given a displacement 100 kilometers north. Okay, and it says that takes 1.2 hours. Okay, and then it says it turns and travels 62 kilometers south. All right, so now I'm on to part 2. What's that 62 kilometers south? It's another displacement, okay, because it's in kilometers. Okay, and that takes 0.9 hours. All right, so one of these is more of the trip than the other. Agreed? Okay, like part 1 is far more of the trip than part 2 is. All right, now that I've got my givens written down, now I'm going to have my totals. Okay, if I want to find the average velocity of the bus, okay, I'm going to need the total displacement divided by the total time. Now, displacement is vectored. I go 100 kilometers north, and then I go 62 kilometers south. What's my displacement? 38 kilometers north, right. Okay, so what this looks like, okay, is I just put in V average is going to be 100 minus 62, or plus negative 62, whichever, okay? And then I'm going to divide that by the total time. So 1.2, okay, plus 0.9. All right, so that's going to give me 38 kilometers north divided by 2.1 hours. So when I plug that into my calculator, okay, if I'm doing the whole operation, it would be 100 in brackets minus 62, okay, divided by 1.2 plus 0.9. Oh, I went times 0.9. No wonder that looked really, really weird. Plus is better. Okay, 18.1. What are my units? Kilometers per hour north. Right, I have to have that on there. Velocity is a vector quantity. Okay, so there's our answer. 18.1 kilometers per hour north. Now, if I give a question like this, I usually have a part B. And that part B is, what's the average speed? How do I do that? Kurt?
Total distance over time, so you wouldn't take away 62 from 100.
Right. Total distance over total time, instead of taking away 62, I would add it. Remember, distance is scalar. It doesn't care whether I backtrack or not. It just cares how far I go. I go 162 kilometers here. Okay? Yes, I only end up 38 kilometers north of where I started, but I still travel 162 kilometers. Right? So if I'm doing this to calculate average speed, okay, average speed, because it is scalar, direction doesn't matter. Okay? So total distance over total time. So that's going to be 100 plus 62 this time, divided by 1.2 plus 0.9. So if I do that one, I'll just cheat and go back here and change my entry to plus. All right. Is that quite a bit different? Yeah. And most of the time, speed is going to be bigger than velocity, because speed and distance always get bigger. Okay, you're always adding, right? But with vectors, sometimes you're taking away because sometimes you're backtracking. Okay, so our average speed for this one would be 77.1 kilometers per hour. Okay. Everybody all right with how that one works? Okay, so if you run into a problem that has two parts, this is how you solve it. Okay, you have to remember that for an entire trip, for the totals or the average over an entire trip, it's total distance over total time. Okay, because some questions will try to trick you, and they'll give you the velocity for part one and the velocity for part two, okay, and then like the time for one of them and the distance for the other. And a lot of people will just go, oh, I've got the two velocities, I add them together, divide by 2, and they totally forget that that's not how you do it. Okay? All right. Maybe I'll just make up another one here that's kind of like that, just so you can sort of see what that looks like. So maybe write this one down as a second example. that written. Okay, let's have a look at this one. So, as we said, this is obviously a question that has more than one part to it. Okay, so what we want to do is write down our givens, but break it up into the two parts. So in part 1, we know the rabbit runs due east at 22 meters per second. What do they give me there? Not speed, velocity. East at 22 meters per second. Okay, magnitude and direction. Okay, that's a velocity. Okay, right there. So velocity is 22 meters per second east. Is it also the speed for that part? Yes, it is. Okay, the speed of the rabbit during that part is 22 meters per second. Okay, but most importantly, I was also given the direction there. Okay, now for the rest of part 1, the other thing we're given is the time, 12 seconds. What we don't have is distance. Okay, for part 1 anyway. We don't have time for part 2. Okay, so what we need to find here, if we're going to be asked to find average velocity, okay, I'm going to need total displacement and total time. And if I'm going to find average speed, I'm going to need total distance and total time. So I definitely need to know what D is for part 1. Can I find it? Yeah, because I have T and V, the other two parts of the equation. Okay, so if I'm taking, let's write down the other givens here before we get ahead of ourselves. Okay, for part 2, right, we know that the velocity for part 2 is 17 meters per second west. Okay, and the displacement is 32 meters west. Okay, how do I know that 32 meters is west? Yeah, it says he turned around. I mean, it says he runs it due west at 17 meters per second, so there's a velocity because it got magnitude and direction for 32 meters. Well, the 32 meters is also west. Okay, it doesn't always have to say 32 meters west. It can preface that with the direction. You have to always be watchful for that. All right, what don't I have in part 2? Time, and I'm going to need that. So I have to do a couple of intermediate calculations here before I can get my total displacement and total time. So my average velocity will be total displacement over total time. Okay, and my average speed will be my total distance over my total time. Okay, I know it looks similar, but remember the little arrow over top indicates that they're vector quantities versus scalar quantities. All right, so if I'm looking at my numbers here, I need to find D. V equals D over T. I need to solve for D. What do I do? Multiply both sides by T. All right, so D equals V times T, so that's going to be 22 times 12. So 22 times 12 is 264. 264 meters east. Okay, for part 1. And in part 2, I've got to find the time. So I'm going to just continue on with this manipulation here that I did. I want to get time by itself. What do I do with V? Divide it over to the other side. So T equals D over V. That'll be 32 divided by 17. Okay, so 1.88 seconds. Now I'm going to keep all those decimals. That's important to realize. I'm not writing them all down here, but I'm keeping them in my calculator. All right. Okay, do I now have enough information to do average velocity and average speed? Yes, because I've got the distance for both parts, displacement for both parts, time for both parts. Okay. Now, you're probably looking at that and going, Mr. Coderre, you only got displacements written here. Well, you're kind of right, except that since this only goes one direction, is the distance and the displacement the same number? Think about it this way. I start right here. This is position 0. And I walk 5 meters east. Okay? My displacement is 5 meters east. What's my distance? 5 meters. I just don't include the east, okay? I traveled in a straight line. If I travel in a straight line, my displacement and my distance have the same magnitude, okay? That's the only time that will be true, okay? But if it's a straight line and there's no turns, distance and displacement are equal. Okay? All right, so now that I've got those numbers, okay, I want to calculate my average velocity. So average velocity means I take 264 meters east and I add it to 32 meters west, which doesn't look like adding, it looks like subtracting. Okay, so 264 minus 32, okay, divided by 12 seconds plus 1.88 seconds. And again, I'm going to keep all my decimals for that one. Okay, I'm going to plug them all in when I do this. All right, so my average velocity it's 232. Okay, anyway, it's just one of those Friday brain farts. Okay, 12 plus, and then to keep all my decimals, I'm just going to hit answer from the last one because that's got all the decimals in it. Okay. All right, so we're looking at an average velocity of 16.7. What are my units? Meters per second. And what's my direction? Okay, this was the bigger, right? Like I went 264 east, I came back 32 west, I still end up east, right? Okay, so that's going to be east. 16.7 meters per second east is my velocity. How does this differ for speed? Right, I just add, okay, the distance on instead of subtracting. Okay, I can make myself really easy by just getting my entry back and changing the minus to a plus. Right, so we're looking at 10.3. Oh, it took the answer. It took this answer. That's why it didn't work. Okay, sorry. I can't just do that because I had answer in there. All right. So 264 plus 32 divided by 12 plus 1 point. Oh, I'm gonna lose it. 88234. It's like 291, right? Something like that. My calculator can't save. I can't go back and grab. It'll be fine. It'll be close enough. All right. So 21.3 meters per second. Okay. Notice I don't put a direction on that because speed is scalar. Okay. Keep that in mind. Speed is scalar. All right. We did that one yesterday, and I don't think we got to that one yesterday. Okay? This one's much easier than the two we just did because it's only one part. Okay? So give that one a try. We're looking for how long it will take a jet traveling at 330 meters per second to travel 400 kilometers. Okay, so we're looking for how long, which means they're asking us to solve for time. Okay, jet traveling at 330 meters per second. Is that a speed or a velocity? That's a speed, no direction given. Okay, and the 400 kilometers, distance or displacement? Distance, no direction given on that one either. All right, so we're looking for how long. Okay, we have to use this formula because that's what we've got. Okay, we've got those three things. We're looking for time. I can't solve for time if it's on the bottom, so I have to move it to the other side. Okay, and then isolate it by dividing by v. So I've got t equals d over v. That'll be 400 kilometers, but I'm dividing by meters per second. What do I have to do to the kilometers? Times it by 1,000. I got to change it to meters. So it's 400,000 meters, okay, divided by 330 meters per second, which incidentally is the speed of sound at 0 degrees Celsius. Okay, so this is a very fast plane. It's not a passenger aircraft. Okay. All right, 400,000 divided by 330. All right, so it's going to take 1,212.12 seconds, okay, in order for this to happen. Okay. How do I convert that to hours? Not 60. That'll give me minutes if I divide by 60. Okay, so it's 20 hours. All right, got to divide by 60 again. Sorry, that's 20 minutes, sorry. And then divide by 60 again. 20 minutes, okay. I only divided by 6. Anyway, 0.3 hours. Okay. All right, so we had 1,212 seconds. All right, are these making sense? Okay, algebra here isn't too tough. Okay, we haven't gotten into any of the stuff that's going to involve a lot of big manipulation. Okay, that one's too easy. Try that one, elevator. Okay, so this one's like a two-part question. Okay, so it's like the bus one that we did. All right, so elevator travels up 85 meters in 30 seconds, then travels 60 meters down in 20 seconds. We're looking for both the average speed and the average velocity. All right, so start out, write out our givens. Okay, for part 1, right, we know that the elevator moves up 85 meters. Okay, so that's a displacement. That takes 30 seconds. So that's our time. Okay, in part 2, we know that it moves 60 meters down, also a displacement. And that takes 20 seconds. So we don't have to do any intermediate calculations on this one. We can go straight to our totals. Okay, and that's going to look like this. Our average velocity is total displacement over total time. Our total displacement is going to be 15 meters up. Okay, and that is going to have taken 50 seconds. All right, so not 15 meters up, 25 meters up. How come nobody stopped me? You're about to say something? Okay, just didn't want to hurt my feelings. I appreciate that. I know that's why you didn't want to say anything, but I'm recording this and I'm going to post it on YouTube. I'll be humiliated if I can't do the addition and subtraction. Okay, all right, so that means it's going to be 25 meters up over 50 seconds, which makes the math easier. Okay, it's going to be 0.5 meters per second up. Okay, so that's our velocity. Okay, if we're looking at our speed, our average speed is going to be the total distance over the total time. Okay, the total distance is going to be 145 meters. Okay, and that's going to take 50 seconds. So that's going to be like 2 point something. Okay, 145 divided by 50, 2.9 meters per second. All right, I need everybody to mask up. I'm going to come around, spray the desk, and you're going to wipe them down.